let's look at graphing some transformations of sine and cosine functions. So if you notice, I have my graph of y equals sine x over on the right, and I'm going to use that as a reference as I build my transformation here of -4 sine of x divided by 4 plus 2. So before we go graph it, let's break down everything that's happening here. So over here, we got that negative, right? And we know that means we're going to have a vertical reflection, or in this case with the sine function, we're going to start by going down. Then we have an amplitude of 4, so that's going to be how high we go up from the midline and down from the midline. And then we have a frequency denoted by k of 1/4. Right, so remember that because my frequency is 1/4, that means my period is going to be 2 pi over 1/4, but really that means my actual full period of the function then is 8 pi, meaning it's going to take all the way from 0 to 8 pi to complete one revolution of this sine transformation. And the last thing I have here is that y equals 2 is my midline. So I'm going to actually start with that. I'm going to go ahead and plot my midline, and then I'm going to use that. So let's just number these real quick so we be thorough here. So I'm going to take this and I'm going to say we have 1, 2, 3, 4, 5, 6 here, and we have -1, -2 here. Okay, so my midline here is at +2, so I'm going to go ahead and put that midline there, and that's kind of the center of my graph, right? Everything's going to be going up and down from there. Now I'm going to go up to 6 because that's 4 higher than 2. I'm going to go ahead and put my upper bound, and then I'm going to go 4 lower, which is going to take me all the way down to -2. So I'm going to go ahead and put this here. Now, I know that it takes me all the way to 8 pi to complete one cycle, so I'm just going to graph one cycle of this, or one period of the function. And so that means over here I'm going to have 8 pi, half of that is 4 pi, half of that is 2 pi, so I'm really going by every 2 pi here. So I have 2 pi, 4 pi, 6 pi, and 8 pi. All right, well now I have everything set up, so I'm ready to graph. And remember, because this is a sine function, it's going to start at the midline, and that's at 2. And now because it's negative, it's going to go down. So it's going to go down to -2. Going to return back to 2, go all the way up to 6 at 6 pi, and return back to my starting point at the midline. And so then we draw our graph, and we're all set. Now we've successfully graphed one full period of this sine transformation. Okay, let's take a look at another one. So this time we're going to be dealing with cosine. All right, so let's start with the same process. First, we're going to identify everything that's happening here. We have an amplitude of 3. You can see I have my cosine graph for reference here. We have a frequency of 3 as well, which now means that the period of my function is 2 pi over k. So that's going to be 2 pi over 3. So that's going to change some things. And then we have a midline of y equals -2. So now let's go ahead and set up this graph based on that midline. I'm going to go ahead and label my y-axis here, and that's going to give me -2, -3. I'm going to go all the way down to -6, although technically I just need down to -5, and then I'm going to go up to 1 here. All right, now I'm going to put my midline here. And again, that's kind of like the center of my graph, at least vertically. And then I'm going to go down 3 because I have an amplitude of 3. So down 3 from -2 is going to go down to -5. And then going up, we're going to go up from -2 to 1. All right, now, if I'm looking at this, right, I have a couple options here. I could just graph all the way to 2 pi over 3 and get one cycle. But I kind of want to show that one period or one cycle of the function happens just from 2 pi, or just from 0 to 2 pi over 3. So I'm going to go ahead and put 2 pi over 3 right here. And then I'm going to use that to kind of space things out here. I'm going to put pi over 3 here. And then I'm going to put Well, 3 pi over 3 is just 1, so I'm going to put this is going to be 1 pi because it's 3 over 3, and then I'm going to have 4 pi here. 4 pi over 3, sorry. Okay, now I know this is cosine, right? And it's positive, so it's going to look pretty similar to what we have over here in blue. But because the full period of the function is 0 to 2 pi over 3, I got to start at the top and return all the way back to the top by 2 pi over 3. I also need to reach my bottom point at pi over 3. And then I'm going to have a second cycle from 2 pi over 3 to 4 pi over 3. All right, so we're going to go ahead and graph this, knowing that I'm going through the midline, trying to go halfway in between my upper and lower bounds here. And so I have a third point here. And now I've successfully graphed 2 cycles of 3 cosine of 3x minus 2, knowing that the frequency is 3, so we would take one more cycle to get us all the way to 2 pi. All right, let's try one more here. And this one is going to have a horizontal shift. So let's look at what happens on this one. Now, in order to identify and be able to graph this without a calculator or without Desmos, we need to factor out this 1/2. And when we do that, we're going to get 1/2 x minus pi. And then we're going to have plus 1 here. All right, so now let's look at all the things happening here. We got a lot. We got a vertical reflection. We have an amplitude of 2. We have a frequency of 1/2, which is actually going to make the period of the function 2 pi over 1/2, which is really 4 pi. And then we have a horizontal shift. Remember, it's always going to be the opposite because of the minus. In order to get back to 0, you have to counteract that. And so that's going to be a horizontal shift to the right of pi. So right of pi. And we got a midline at 1. And so now we can go ahead and set up this graph. Right, now what am I going to do here in terms of my numbering, right? I'm going to have 1 here as my midline, and I got to go up and down 2 from that because that's my amplitude. So I'm going to go up to 3, and I'm going to go down just to -1 here. So we're going to put our midline here at 1. And again, I'm doing these just to show that it just kind of helps me see where my graph is going to lie and also line up some of the kind of crucial points on the graph, right? Okay, now let's talk about what's going to happen here. Well, we need to, in order to graph one revolution of this, or one cycle, or one period, we need to go from 0 to 4 pi. But we have a horizontal shift right of pi, so I'm actually going to go, let's put 4 pi about right here, and that will give me, I'm going to go by pi, and I'm going to actually go all the way to 5 pi in this case. So I got 2 pi, 3 pi, 4 pi, and 5 pi. And don't forget, like I almost did, to label your x and y axes. Okay, so now what I like to do with this when I have a horizontal shift is I want to think of my starting point, right? And that'll kind of help me center everything so that I can do the rest of the graph. Well, my starting point is not over here anymore, right? It's at 1 because of my midline, and we have a sine curve. But actually, we shifted over, so it's over here at pi. Now it's going to be going down because it's a vertical reflection. And so I'm going to go down to -1 at 2 pi, back to 1 at 3 pi, up to my upper bound at 3, and I'm going to complete one cycle here. Okay, so let's just go ahead and draw this. So I'm going to have going down and going back up and completing one cycle. Here we go from pi to 5 pi. Keeping in mind that if you were to keep going, right, you would go over here back to 0 here, and it would keep repeating, right? So there is a transformation with a horizontal shift right of pi.